2, 1. Contact is the secret, is the moment when everything happens. Contact. Let's make contact. 3, 2, 1. Classroom. Contact.
Air is there.
You can't see wind.
But you can hear it. You can see it blow things around. And you can feel it.
And you can have fun with it.
You can even travel on it.
Wind is air, moving air.
And even though you can't see it, air is a fluid.
Sort of like water.
It flows. It has weight. It takes up space.
It behaves in certain predictable ways.
Air. You can't see it.
But it's definitely there.
Hi, I'm Ken Scott. Air is there, all right. You can only see it in action, but it's all around. See? Air. Air is real stuff. It has mass and volume, just like you. I hear some doubters out there. Okay, these demonstrations are guaranteed to blow all your doubts away. In my left hand, a plastic cup. In my right, 2 tissues. I stuff the tissues into the cup. Notice, ladies and gentlemen, that my hands never leave my arms. I turn the cup upside down and place it into this handy tank of water. 1, 2, 3, observe. The tissues are completely dry. How come? Air, that's how come. The air inside the cup takes up space. Water can't move up into that space and get the tissues wet because the air is already there. Let's see it again in slow motion. Instant replay. A trick, you say? No, science. Here's another demo for the unconvinced among you. On each side of the scale, a small tank of air. They each weigh the same. I let the air out of one of the tanks. See, the air in these tanks weighs something. I still hear lingering doubts. Some of you are tough. Okay, take a look at this.
Keep her into the wind so we don't get any wind in the sail.
My dad's an engineer. His name is David Geiger.
Okay.
He really likes to sail.
Leader, I go.
I'm his daughter, Karma.
Want to take the wheel, Carm?
Okay.
I'll play out tonight.
I like sailing too. Dad builds buildings with a new kind of roof. The roofs he designs are made of a new fabric, not steel and wood like regular roofs. Dad, how does the sail work?
When the wind's in back of us and we're going with the wind pushes the sail, and that pushes the boat. It's the pressure of the wind that works then, and that's like our roofs are lifted by the internal pressure, which we make by fans. They're lifted up.
Does that mean that the roofs that you build and the sails we sail, does that mean that they get their shape from air?
That's exactly right, yeah.
One of his roofs are going to be inflated today.
I'm going to go first. Good, you can start now.
This is scary.
Yeah, you got to be careful. Hold on tight.
I got it.
Okay. You're okay?
Yeah, this is fun. How big is the whole stadium?
The stadium covers 10 acres. That's about the size of 5 football fields. Come on over.
What's this made of? I mean, you think of fabric clothes and everything, but never as roofs.
The fabric is made of Teflon coating on fiberglass. Fiberglass is very, very strong, and it's very lightweight. This fabric weighs about 1/4 pound per square foot, and that doesn't seem like a lot, but if you have 400,000 square feet here, and you add the cables and the clamps, the roof weight's 1 pound per square foot over 400,000 square feet is 400,000 pounds, which is about the weight of 15 cars. We have fans, mechanical fans, that move air.
Is the roof held up like the sails on a sailboat?
In many ways, that's a good analogy because we have wind pressure is pushing the sail, just like the way the air pressure under here pushes up the fabric. And that causes it to rise, almost like a cake rises in a pan. The edge comes up first, and it slowly lifts from the edge. And in about 2 to 3 hours, it will have risen almost 200 feet in the air. That's the height of a 20-story building.
I've just received word that some of you are still skeptical, which is okay because it gives me the chance to show you some more stuff. Here we have the official 3-2-1 contact potato popper, patent pending, a clear plastic tube in which I insert a regulation Idaho spud. I press the plunger and pop goes the potato before the plunger even got near it. Why? Because something was in the tube that takes up space. What's that? Air. The plunger pushed the air pushed the potato. How about that? Let's see it again in slow motion. Instant replay. And now for my final demonstration. I'm sure this one will flatten any of your lingering doubts. I'm heating this metal can on this ordinary hot plate. As I heat the can, I'm also heating the air inside. When air gets hot, it expands. Even as I speak, hot air is flowing out. I seal the can with this lid, remove it from the grill, and what smushed the can? Air. The air all around it. When I heated and sealed the can, very little air was left inside. Too little to stand up to all the air pushing in on it. Air pressure crushed the can. Air in action. You wouldn't jump out of an airplane without life support. In this case, a parachute and air. Ellen Jeffries of the Connecticut Parachutist Club is going to teach Robin how to jump.
I can't believe that looks like so much fun.
Hey, hi.
I'm ready. I'm ready right now.
Good. Well, hey, let's go get started. You brought the note?
I'm so small, and this parachute is so big. Oh, that's neat.
This one operates the way your basic parachute does by catching air inside of it, okay? And all of that air that it catches inside of it slows it down. Now,
Ellen was telling me that it has to do with surface area. The more surface area hitting the air when you come down, the more resistance there is, and the slower you go.
And that's going to make...
It takes this much surface area to slow me down. What keeps the parachute up?
Okay, now see it's inflated like this?
Yeah.
Okay, air isn't just nothing. All right, and as the parachute comes down, it catches more and more air in it, and it builds up pressure. And you need a big enough piece of material like this to catch enough to hold your weight. And the heavier you weigh, the bigger it has to be. That's why it's so big. You know, if it weren't big enough to support your weight, you'd come down a lot faster than you wanted to come down, and your landing would be like jumping off of a 3-story building instead of off of something about yay high. Okay, now pull. Okay, now then, I want you to take the static line and I want you to walk back that way with it, okay? Notice how the line's going?
Yeah.
Keep going, the parachute's coming out, and at that point you detach from the airplane, okay? Swing around, okay, and get out here. When I tell you to go, you look straight forward, and you kick off with your feet and push off with your hands, and you count. Arch 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. Check the canopy. If not, look, full arch. Arms through there, and an arm through there. Heavy? Heavy. Go.
Arch 1,000, 2,000, 3,000.
Your canopy just open. Look up and check your canopy. It's a good canopy.
Class is over. I'm ready for my first jump. Ellen went over the whole jump procedure again. This is it. Fantastic. I was just floating.
Air is real stuff. It takes up space. It weighs something. It can crush a can or hold up a roof. Air is there, and that's not hot air. It's a fact.
321 Classroom Contact is a production of the Children's Television Workshop.